Hello. Hello, am I audible?
Yes, sir. You are audible.
Okay, I think lots of the people's only you are present here, but I will start these things today class and today I will explain the basics things and tools about the QGIS because lots of the in QGIS tools you don't know about these things. So I will explain these things, and we will do a practical part, that is georeferencing. I will not do the much more part in QGIS because most of the people are not coming in this session. I think they today is weekend, and so most of the people are going for uh, somewhere in evening. So I will explain these things very little bit about the QGIS. So let us start. Okay, my screen is visible to you.
Yes, sir.
So we have read about all these things. What is the vector and this raster and these things. Now come to the main things which I want to explain. Uh, what is the coordinate reference system? So can you tell me the what is the coordinate reference system?
Yes, sir. Actually, our surface is a sphere kind of thing. It's not a flat. So, whenever we are mapping something, then we have to plane it in a 2D plane. So we use some kind of coordinate reference. There are different coordinates, just like geographic and something else. One is more than other.
Hmm.
So it's a kind of latitude and longitude. We are putting at some known zones. So that map or something is going to be coordinated, and there is going to be a proper reference.
Yes, you are absolutely right. This is the coordinate system. So, exact definition of the coordinate system in a simple word: a coordinate reference system, that is oftenly called as CRS, is to describe the location of any place on Earth using numbers. Its number. That number is a coordinate like latitude and longitude. That's all. Okay. So it is a number which described your location in a on a earth system. That is the coordinate reference system. So CRS tells GIS software how to place maps and data correctly on the earth. Without CRS, your points, lines, and images would appear in a wrong place, as we will see in this practical section. So there are two main types of the CRS. The first is geographic CRS, that is WGS84, and its code name is EPSG, that is 4326. If you are put this value in what is the EPSG, we will see in this part. And description of this is the latitude longitude around a Earth. And second one is the projected CRS, that is VTM or wave marketer. Use X and Y meters on a flat map. So in the case of the first geographic CRS, that is your coordinate is in latitude longitude. But in the case of CRS, projected CRS, your coordinates are in X and Cartesian format, X and Y. That is a meter in this. So it is an angle. Latitude and longitude is an angle, and degree is a unit. And good for the global mapping is oftenly use you WGS 84, and its coordinates is EPSG coordinates. What is the EPSG? I will explain later. It's a 4326. Remember, 4326 is good for your universal coordinate system. So that is the global system. Now projected CRS also called a flat map system Coordinates are to 2D using XY in meters, as you explained. That is a 2D map on XY in meters used for area calculation, distance, and UT coordinates. It's divided into zone wise. So uh, now I have repeatedly many time explained EPSG. Every CR is a code like EPSG. EPSG codes help QGIS or any software, GIS software like RGIS or other, to understand with the CRS you are using. Why CRS is important in this uh, in GIS? Without CRS, map appear in a ocean. Most just with take a map and TIFF map and import in your GIS format, and in background open the base map. Then you will see the without this georeferencing or without CRS information, this will go on the your ocean. With CRS, it's fixed exactly where it should be. It's suppose that you have a map of the Delhi, then it should be exactly overlap on the Delhi on a base map. Layers do without CRS, layers do not match, and you cannot measure the distance. So EPSG, what is the full form of the EPSG? EPSG is if you take its full form of EPSG, that is European Petroleum Survey Group. But in GIS, EPSG is just a code. Don't go to the this full form. It's because most of the this GIS software is developed by the European agency and military agency. So European Petroleum Survey Group has developed a code that's called the EPSG. It's just a code system used identify coordinate like WGS 84 and UTM. For WGS 84, EPSG code is 4326.
Sir, only this screen is the model 3 coordinate reference system. Is
Yes,
it only thing?
yes, I cannot.
Uh,
What are you saying? Please repeat your question.
Sir, actually, I'm saying your screen is just visible module 3. Is, like,
Yes, I'm just explaining
okay,
this. Okay, I'm just
okay, sir.
explaining, journal explaining. I will explain these things. What will I
Okay,
read?
sir. Okay.
Okay. So I just give you the overview of the what is the coordinate reference system. As you have told, now one term is the EPSG. What is the EPSG? EPSG is a every CRS, that is a coordinate reference system in the world, has a unique EPSG code. This tells GIS should uh, what kind of coordinates you are using. So for WGS84 you are using 4326, and for wave marketer it is nearly 3857. And suppose that for Delhi region is a UTM zone is 43N, so its EPSG code is 326443. So this is the overview of your coordinate reference system. Now model 3 we will learn understanding coordinate system, how to convert UTM to decimal, and how to convert decimal to degree to UTM, basic GIS concept, special data types, vector and raster. I have explained, I think I have explained these things, basics of the coordinate system and projection and georeferencing. So decimal degrees to UTM, uh, how we can change? This is a formula, simple formula. With formula you can change, and on a GIS platform you can also change, and you can make a formula on Excel. Just put the value and you'll get the answer. Your converted coordinate system. So to convert decimal degrees, latitude, longitudinal to UTM, that is universe transverse Mercator coordinates, you need to follow a few steps. This conversion involves some geographic principle because UTM is a map projection that divides the world into zones, while decimal degrees are just latitude and longitude coordinates. So step is the First, understand the basics. Decimal degrees represent geographic coordinates as latitude and longitude in decimal form. Example 40 degree 0.7218 and 74 degree 0.0060 for New York City. This is the coordinate of New York City. And UTM divides the Earth into 60 zones, each 6 degree wide in longitude, and projects each zone onto a 2D plane. Each UTM coordinates has a easting and northing value in the meters. So, second, this is the basic things how UTM and decimal degrees are divided. So, identify the UTM zone. The next step is the identify the UTM zone. Each UTM zone is 6 degree of longitude wide. To find the it means that the vertical lines, the difference between the two verticals, and that is longitude, is 6 degree. Its wide, its width is 6 degree, and 1 degree, you know about how much kilometer, 111 kilometers. So multiply with 6 degree, this one. To find which UTM zone a given longitude belongs to, use the formula zone number longitude plus 180 degree upon 6 plus 1. For example, longitude of 74 minus 74, this is a New York City, so zone number is 18. New York City is UTM zone 18. You can check on the Google and these things. This is the way. Second, apply conversion formula. For this, we use a specific formula derived from map projection, mathematics, that transverse market and projection. This can be complex, but most people use tools like Geographic Information System (GIS), libraries like projection in Python, or online tools. We will also see how to georeference and reproject in Python, and in QGIS we will see later. Here a high level overview of how the conversions were. Input latitude, this is the latitude angle phi, and longitude angle is lambda in decimal degrees. Output UTM easting and northing in meter. The general formula n is natural log 10 pi upon 4 plus 5 by 2. So a reference a left side example WGS64, calculating the scale factor and false, and don't go in deep. This is a simple formula. Convert latitude for calculating the latitude angle and longitude angle. So from this, and now finally central meridian of UTM zone you have calculated from this zone number multiplied by 6 minus 183. This is for your UTM latitude. Easting and northing formulas are more complex but depend on the Earth's radius, eccentricity, and other geometric factor. This is the general formula how GIS software calculate your reprojected value. This algorithm is used GIS, but this as you go for the higher order, so formula will be complicated. So you use the UTM conversion tool. I will tell you how to make a conversion tool on Excel, in Python, and in QGIS is by default it has been given. So no need to make any conversion tool. So the easiest way to handle these calculation is by using tools like online UTM converter. Many free ones available. You if you are searching on Google, then see the most of the online tools are available. Just put the value and you'll get the answer. Besides this, some GIS software like QGIS and RGS is very good for this. One minute, please. Just give me 1 minute. Okay. So beside this software, like some programming language, that's R and Python libraries. Like in Python, the module the PyPros based on the pros library, which handle these conversion easily. So what is the easting and northing? Easting is the latitude and northing is your longitude. Easting measure in meters from the central meridian of UTM zone. False easting of 50,000 meters in added to avoid negative numbers. And northing for easting in the northern hemisphere, the northing measure from the equator, while in the southern hemisphere the false northing is in the 10 to the power 7 meters is added to the northing value. So this is the for this correction values. If you are converting this by default, this is given in your software. Just give me one install. Next is so these are the way for the converting these things. So I'm not explaining in a detail. So general formula where variables are given, the n for the northing is E for easting, Z for UTM zone number, and these are the universal letters. These things when you are using this seeing this, what is the meaning of this? And zero for northern hemisphere, is zero for false sting, and the 50,000 we have to 5 lakh we have to correcting these things. K0 UTM scale factor, equatorial radius of the earth is this, and meter for the WGS 84 datum plane, and fretting on the earth is reciprocal of this 1 upon 298 for this. So constant is the UTM projection use a reference left side is WGS 84 is the most common. So we will use WGS 84 and then we will see the conversion factor. So this is the way for step to convert UTM to latitude to longitude. How we can directly we cannot convert it. First we have to correct for this. Uh, First in actual sting value we have to subtract this 5 lakhs correcting for this. Then we will convert. For northing similarly northing we have to convert subtract this value, and step to put this in uh, Z is your UTM zone number, put in this formula and calculate the footprint latitude. The next step involves foot point latitude or footprint latitude means it's a landmarks. It's where is your and that is the modern name is footprint or foot point is a land location, which is a approximation of latitude on a perfect sphere. This is done through a series of mathematical expressions which are too complex to calculate manually but can be simplified using software tools. So these are the formula which I have step by step I have written this thing. So next, why we need GIS we have seen in first class. So I'm not image pixel I have we have seen this bit depth we have seen. So what is the bit depth and what is the matter, how this is important in image classification. Grid and mesh we have seen. Grid structure, what is the grid structure we have seen. So different features in vector we have seen. About the raster data and no data we have seen. Key difference between the vector and raster we have seen. So now come to the main point of the georeferencing. Georeferencing is defined as the process of assigning a geographic coordinate system to a layer of data. So what is the georeferencing? If someone uh, asks you what is the georeferencing? So georeferencing meanings in a simple word, not I'm going to a very long definition. What is the georeferencing? In simple word, fixing a scan map or image on a real world coordinates. Okay, if you have a map of the Delhi region, then it must be overlap on your GIS software. That is the georeferencing. That's so. Next is why do we georeference? To use scan map to match the map satellite or shape files, and for to analyze the old maps with the current location data. So that's why we are using the georeferencing, because suppose that you have a map of Delhi region, suppose that you are standing on a near to the Qutub Minar, and you want to see on map, then it must be your coordinates lie on your GIS software or real world coordinates. So for this we are doing the georeferencing. So imagine you a scan, that's the scan a paper or map. The image has no location information, but you know where some places are on the map. Example, if you are standing near the Qutub Minar, so you tell the QGIS or other software of this Qutub Minar latitude, longitude, then you can easily point out on a GIS software. So one question in your mind for georeferencing, how many points are needed? Nearly 3 points, minimum 3 points you need it for the for basic transformation of geo referencing process. For recommended 4 points is good. If more than 4 points is a better accuracy, more points for better fit and less distortions. So try to find out the more points, but if you have a minimum 3 point, then your work your georeferencing process will work. Simple steps for georeferencing in QGIS we will see later. First, we will read about the what is the georeferencing. So, how georeferencing works? First, control points identify known location on the Earth surface in the image, called ground control point, that is GCP point, to align the image with geographic coordinates. Alignment once alignment, the image can be used to create accurate maps, performs spatial analysis or combine with the other dataset. Key benefit to use accurate map, change detection, spatial data integration, and resource management. These are the things with the help of the georeferencing you can the correlate these things with your uh, other base map or world map. So real words example, this is why it is important, which I have already told you in a simple words. So these are the layer by layer georeferencing layer. So I have given the detail about the coordinate, what is the coordinate reference system. So a coordinate reference system like a maps guide that tells you where things are on the Earth's surface using coordinates like latitude and longitude. It ensures that the location are constantly and accurately represented on maps. Simple explanation, globe example, just like a globe use latitude and longitude to show where places are. SCRS helps map system pinpoint exact locations, and different system is there are various CRS depending on the map's purpose. Some are better or large areas like countries, while others were best for smaller region. So why it is important? CRS, as I have told you, CRS ensure that when you see coordinates on a map, they correspond to the same spot on the earth, making maps reliable and consistent, which I have already told you with the example of the Qutub Minar. If you are standing near to the Qutub Minar, then it must be exactly overlap on the GIS software. So these are the some coordinate system map projections, and there are only two, WGS 84 and the projection map. In projection map system, there are lots of the uh, projections are available, like on the fly projection, easting, northing, which we have not go into details. So just read the map. What is the map projection? Map projection are method used to represent the 3D spherical surface of the earth on a 2D plane, like a paper map or a computer screen. A coordinate reference system defines how these 2D maps relate to the real world location. The choice of projection and CRS depends on the area being mapped and that analysis and the data available. So these are the 3D maps uh, geo- where we have to if we have a correct georeference map, then suppose that this is the in India, here the India. So if we have a India map and that is a corrected georeference, that is the your India map is a 2D and which is correctly overlap on this. So you can say that you corrected correctly you reference your this your map, India map. So these are the method how I have shared this PPT to all of you, how this in the georeferencing process, how this will algorithm will work, and how the GIS is used these algorithm for georeferencing process. So these are the things for the universal transverse marketer UTM CRS in detail way, which I have already explained. What is the UTM? So if you read these things, you can easily understand. But in a simple word, I want to explain what is the this UTM coordinate projection system. So its full form is a universe transverse marketer. It is a system that helps to show location on Earth using meters instead of longitude and latitude. That's the simple explanation. You can divide the Earth into zone as I have explained in a starting, and each zones it tells location using x and y coordinates in meters, and the difference between the latitude is the 6 degree. Just like a graph paper, it helps you. If you have seen the graph paper, this is the your graph paper. See the it is divided into zone 1, zone 2, zone 3, zone 4, and each zone separate from the this from this to this is the distance is the 6 degree. So and why we use the UTM? Is it for easy to calculate distance and area, but in a WGS84 distance calculated in a degree. So if you're working on the suppose that land work, if you're working on land classification work, so you want to make a blueprint of any building and these things, how much your building is far from your river and highway, then you can use the UTM coordinate system because easy to calculate distance and area, was great for local or regional maps, more accurate for engineering and planning. So simple that how it looks like in WGS84. Suppose that the coordinates look like this 28.6 60 degree north and 77.20 for the east. This is the symbol for the WGS84, but in the case of the UTM this must be 72 000 and northing for 31 60 60 00 this way. So these are the division, how the and each division depend shows the your uh, latitude and longitude, and the how much these are division, these are the 60 vertical zones, 60 vertical zones these are the, and each zone is 6 degree wide. From here to here the distance is 6 degree, and 1 degree is the 111 kilometer. Just multiply this thing that then from you can easily calculate from here to here the how much distance. So the division is the 60 division and 60 vertical zones. Each zone has a number 1 to 60, and for the and or as for the northern hemisphere and the southern hemisphere. So suppose that Delhi region, you will choose the 40 degree north, Mumbai region 40 degree north, New York and USA, that is the 18 degree north. These are the way for. So now we will see the some what is the difference between an confusion a GCS, what is the GCS and PCS, and datum and geographic coordinate system, a projection and projected coordinate system, what is WKT and WKID, the define projection tool and the projected tool, projection on the fly and the geographic what is the difference between these two, what is the transformations, a special difference in coordinate system. These are the some small things oftenly be always confused with this, and we'll see this. So what is the difference between the GCS and PCS? GCS is a geographic coordinate system, is refer framework that define the location of features on a model on the earth. It's shaped like a globe, spherical, its unit are angular, usually degrees. And PCS, a projected coordinate system, is flat. It contains a GCS, but it converts the GCS into a flat surface using mathematical algorithm, that is the projection algorithm, and other parameters. Its units are linear, most commonly in meters. So this is the map for the PCS, and this is the map for the GCS. So a GCS is necessary for data to know where exactly on the Earth's surface is located. A PCS is necessary to draw the data on a flat map. So this is your point location. Suppose that you want to know the distance from here to here, then PCS is very useful. And if you want to locate yourself on a map, then GCS is very useful. So next is the what is the difference between a datum and a geographic coordinate system. A datum is a key part of the geographic coordinate system, GCS. So the datum determines the model of the Earth shape called spheroid, and how this model is positioned related to the Earth's surface. Since the Earth is a perfectly smooth or round, different datums are used for different regions to best represent the Earth's surface in those areas. So this will be, I think, it is not clear to all of you because it is not written in a simple language. So I'm trying to explain in a simple language what is the datum plane. So datum plane is like a base reference surface for which we measure location, height, or depth on the Earth. That's the in a simple and how it is correlate with the this geographic coordinate system. In simple, datum is a starting point. It's like a ground level that GIS or GPS are used to calculate where something is on the Earth. So suppose that imagine you want to measure height of a mountain. So need to know height from where. We use sea level or some references as the datum plane. That is the datum plane. So that's the simple. Suppose that you want to measure the height of the your Himalaya hill. Sorry, hill. It's a mountain. Himalaya mountain. You want to know the, so you have a reference point from where you have to measure. So that reference point or reference plane is called the datum. So and for reference points have a fixed latitude and longitude. So it's connected with the geographic coordinate system. So if you go in a detail deep if when you are reading about the DM digital elevation model, there are two types of the datum, that is horizontal datum used for the location, example WGS 84, and the vertical datum used for the height elevation, mean sea level, from mean sea level it is measured. So next is your what is the difference between the projection and a projected coordinate system. So a projection is a method used to represent the earth's curved surface on a flat map. It is one of the components in a projected coordinate system. A PCS defined how project a specific model of the earth on to the flat map. It includes a projection, the mathematical method used to flatten the earth. A geographic coordinate system define the model the earth being used. Units usually meters to measure distances. What is the difference between the WKT and WKID? This is very important. These are both means of identify coordinate system, so you can be sure that you are using exactly the same parameter as someone else. So WKT is stand for the well-known text. It is a string that what is a string we have read in Python that defines all necessary parameter of a coordinate system. Save a projection file.prg for any coordinate system and open it a text editor to see its WKT. And WKID stands for the well-known ID is a unique number assigned to a coordinate system. When you if you have work on the ArcGIS, then there is a automatically generate FID in your attribute table, like say file or raster or point save file. This that is the WKID. You can find the WKID in the coordinate system details window. Once you know this number, it is a handy way to search for the coordinate system later. So this is the for your well-known text WKT, and this is for your WKID. The authority of the WKID will either be EPSG or ISRI, but these numbers don't overlap, so there are no need to worry about which is authority defined by the define the ID. So by default, this ID will come in when you are doing the GIS processing. So what is the difference between the defined projection and the tool and the projected tool? The defined projection tool is used mainly when data has unknown coordinate system. It reassigns the coordinate system information in the metadata. It will not change the actual coordinate values. The projected tool converts all coordinates from one coordinate system to another. It also updates the metadata information. So this is the nothing, and same thing as previous. What is the difference between a projection on fly and geographic transformation? Projection on the fly is what RGI does to resolve conflicts when you data in a different coordinate system than your map. If you did not have a projection on the fly, you would not be able to draw the data before first converting it to the same coordinate system as the map. So it's a type of the projection system. No need to go in a deep for this. Next is what is the difference between a spatial difference and the coordinate system? So both things are the same as GCS and PCS. So in short, the coordinate system is a part of the spatial difference, which, which provides the details uh, needed to use a spatial data accurately. So these are the things which I have already explained these things. No need to go in this. So these are the basics of the your georeferencing part, and we will do the try to georeference for this uh, a map on a QGIS. So if you have any question related to this, please ask. Otherwise, we will go to the for next and open the QGIS.
No question, sir. Please go ahead.
Yes, I'm opening. Okay, thank you. So QGIS is opening. So Okay, I have already shared the some setup file for installation of the QGIS. If you, I think you have installed. So when you will open this QGIS after the installation, so this type of the interface will open. Here the project, a new project, empty project is given. That's the by default is the 4326. It's a APSG, which I have already told you. By default, it is a universal coordinate system, global coordinate system, you can say this. So click on this, then your projection, your project file is in your WGS84. So now next thing is what is the next things? Next things is first to know the this about these things. What is the these project editor layer settings plugins and processing SCM GIS? What these are things, and what is these tools like these we will take a little information about these tools, and then go for the georeferencing process. So fundamentals of QGIS. So what is QGIS? I have already told you, this is a simple symbol of the QGIS. So installation processes, I have already shared the QGIS setup file, and this overview the QGIS menu bar. When you will open the QGIS interface, which I have showed you, and see these, the top is called the menu bar. These are the menu bar: project files, view, layer, setting, plugins, vector, raster, processing. And the second, these are the toolbar. These are the toolbar. Each tool have a different bar. We will see one by one. This third is the panel. This the browser is the third is the panel bar, and this is the map view. And fifth is a status bar, where you will see the your others, that's coordinate system, and this information you can see here. So this is a graphic user interface of the front end of your QGIS software, and this is the free software. So when you will open your project files, then you will see the icon of the new from template, open from, open, recent, close, save as, save to, revert properties, and import, export, new, print, layout, models, and exit query. Each have a different meaning, and it's have a different work. So we will see one by one. So in editor, you will see the lots of the paste feature as add animation, and these things you will see. What is the meaning of this? I have already written here, but it is better that when we will do, then we will understand better. So I have shared this thing, I already shared these things to all of you to see. And the third is the view. In view, there is in these all things which you will see the new map view, processing, and these things. Layers, the most important is layers: a create layer and add layer. From here you can add a vector layer, raster layer, or your point data, like in CSV or text format. You can add raster calculator. You can use the raster information and these things. And in this, there is a section is called a georeferencer. So we will do the georeferencing process in this database. It DB manager, database manager, and processing tool. In from tool, you can search the tool for the others, like if you want to buffering, if you want to merge vector analysis, so go to the tool and search this. So vector georeferencing tool, so these are the general tools, and how it looks like the QGIS I have told you. So now the most important thing is the QGIS plugins overview. So when you have installed, then by default the most of the QGIS plugin is have already installed, but you have to install. Suppose that you on first time you are using the QGIS, then you have to install a georeferencing tools in QGIS, and where you will where you will install this QGIS plugin, so that from plugins you will connect the this and there are two way for installing the QGIS plugin. The first is manage and install plugin, and second one is the Python console. By scripting you can install. So these are the property of the plugins, plugin art architecture, types of the plugin: core plugin, external plugin. External plugins means by GIF format. By default you will install from the Chrome, and in a GIF format, and from browser install on your this QGIS environment. So these are different way. Plugin management options: install, upgrade, downgrade, or uninstall plugins, which we will see in the this. So when you will use the plugin setting, see the lots of the things you will see: add, manage, delete, and the reinstall, all things which you see here. Setting tab overview: what is the setting tab in the plugins dialog allows you to configure which plugins are displayed and how they manage in QGIS. Key options: check the updates for startup, set the frequency of update, and notification for install plugins, example every startup, and daily, weekly. So so also experimental plugins. So plugin repositories is also available. Default repository just provides a official open repository. Adding custom repository from you can also add. So these are the interface of the plugin, and what each browsers will tell you: upgrade, install, not install, new, and these things. You can view plugin details when you have installed this, and these are 30 QGIS important plugin module you have to install in your when first time you are using the QGIS. Quick map service, and these are the Google Steel View layer, Open LiDAR tools box, semi automatic JIT, time series explorer, density analysis, time manager, OSM downloader, add to felt, and freehand rasters, and Sentinel hub, and Azure. These are the very important plugins you have to install. And how to install we will see here. Install in GIF format, which I have already do, that is external plugin. If you'll do, and from Google, install the master file of your plugin module, and from browser you can install this. Otherwise you can by default from installation, then QGIS by default this will be installed in your system. So next is the Python console. How Python console will work. QGIS Python console overview. The QGIS Python console is an interactive shell that allows user to execute Python commands. With the help of Python commands on a Python console, you can also install the your plugin, interact with the QGIS object, and write script using a QGIS Python API. That is what is the API which I have explained in yesterday class. It includes an integrated console and code editor based on the Scancellus 2 package. With a powerful environment for Python scripting with QGIS, the console can be plugins. Go to the Python closures, or by pressing Control Alt plus P, you can enter in the Python console plugin. So these are the some toolbar. when you have entered in a Python console plugin to interface. So clear console import class run, you will see here. So this look like this, just here the Python symbol you can see here, and by easily you can write the Python scripting when you are expert in the Python. So you can use Python on QGIS. So let's do some practical work on this with the QGIS interface. When you'll click on this, then you can see the browser panel 2. Just open the browser panel 1, then you can easily result view you can see. So when you will use the plugins, so plugin and install, so go to the here and search for the this georeferencing plugin. So one thing you will see when I'm click on the plugin, there is a SRTM download manager. Don't confuse with this. I have already downloaded the SRTM downloader, so that's why it is showing. But in your case, this will show the only two. So I click on this and right here the georeferencer tool. Geo. One. The spelling is geo. Anyway, I will check this in Google. And just right here the georeferential tool plugin in QGIS. So georeferential plugin is that is okay. That is a georeferencer GDAL. Just right here the georeferencer GDAL, or only right here the GDAL.
Sir, you write just geo referencer, sir.
I am writing this thing geo references, but it is by default this is not showing. I think in case in your case this will be visible because I have already installed this plugin. That's why it is. I think not. It is visible here.
Here, when I searched it, I got geo referencer extension.
Geo referencing. Let's just install this thing. So
Geo referencer extension.
Georef.
GEO. GEO.
Geo.
Search it, sir. GEO. Then search. Enter. You're not getting it.
No, it is not. By default, this will be busy. Okay, anyway.
Otherwise, you check it in installed, sir.
Yes,
Can
I
you
have
check it?
already installed. That's why it is. I think it is
Okay, okay.
not showing here. So next things, what will you do? Uh, Enable the georeferencing tool. So open. You have opened the QGIS. Go to the raster, and in raster, go to the georeferencer tool. Uh, Here the conversion line, database, raster calculator, free and not freehand. Just see. In this case, it is showing in a layer, that is georeferencer in layer. So this type of the window will open. Just go, and when in this is the new version of the QGIS, but in some in the old version, or I don't know, from my set of file which I have shared to all of you, from these you are using this type of the setup file, or from internet you have installed. So in case it may be in raster, this tool, don't go to the freehand raster georeferencer, or in case layer, this is georeferencer. When you will install the georeferencer GDAL, that's tool name in the georeferencer GDAL, then this type of the interface will open. Just try to install. If not, then send me the screenshot, I will tell you. Okay, now these are a tool. From here, the from raster you can open raster, or from this icon you can also this open the raster. So next thing is, you have a raster file or map. So I have a raster file which here. That is the raster file is given here. So I'm just going here. So latest SOI map on TIFF version. So this is a TIFF file which is not georeferencing. So when I just move it, this there is no any coordinate system is visible here. Just see here. So it is a it's just a map. It is not georeference map. So when you will just select the pan, and when you will zoom it, then see the coordinate system. This cross section, this is the latitude is your 81 degree 45 minute, and longitude is your 25 degree 30 minute. Similarly here is your latitude is 82 degree 25 minutes. So I want to georeference this in a WGS 84. So I have to convert this in 85 minutes, 81 degree in a degree decimal. So simple calculator we will use, or do with online we will convert these things. So and here the points for adding the points are given. This for 8 points you will. So the first we will convert this uh, in a decimal degree. So 81 degree and 45 minutes. The first is 81 degree 45 minutes, and it's long. This is the latitude, and because this for this line this is given, and longitude is 25 degree, 30 minutes. First convert this and write in this in a text file. So write the notepad right here. The first coordinate system is 81.4 sorry 81 degree, 45 minute, and this is your longitude, and latitude is 25 degree, 30 minute. So we will convert this online. So latitude is for first coordinates is longitude is this first coordinates, and the second is So I have converted all degree minute into degree decimal. So we will use this in our georeferencing process. So now next things we have to select the GCP. This is a ground control points table. Now we are going to select the GCP ground control this tools. So where is the ground control tools? We have to check here. No, it is not given here. It is open vector since there is some tools must be. Okay. Okay, this is the tool, ground control tool. Okay, so this is the tool for the enter the map coordinates for this. So here the algorithm is given for this in which you want to uh, in which coordinate system you want to georeference. So I want to georeference this in a WGS84. So this is the my first coordinate system. And what is the easting and northing? It means the easting and northing means it's a latitude and longitude. So before this, I will go to the setting and by default use this WGS84. And generally these are the algorithm transformation type of the algorithm. Generally we will select the linear type, and each type of linear, element, polynomial, and each type have a different meaning for. But in the case of the map, and when you are using the this georeferencing georeferencing for simple purpose, so we will use the linear. So just we will do this later. So just select here, and we will select this WGS84, and our coordinates is here. The x is your this is the 82 degrees longitude, that is your y. And this no, y is your this 25 degree, and this, so this is your y, that is longitude, and x is this 81 degrees. When you will use this these are the dx pixel non-available non and by a non-available. When you will do the georeferencing process from here, then this will show. And residual pixel must be the this is the basically error in your georeferencing process. When you will this residual pixels value is must be less than 0.7, then you can say that this is your correctly georeference. So next go to the second coordinate. Sorry, I will take this pan, and the my second coordinates is here. Take this again, and next your this. Anyway, 82.0028. Just write here the 82. Okay, make it this. Again, it is showing 00. So now this is the second coordinates. Now go to the third coordinates, third points. This is my third points where the cross section is given. Anyway, this is the cross section point. Just see here, this is the cross. So I will put the value here. 82.75. Okay, when you have done this thing, so the see, minimum 3 points are necessary, so that's why it is showing its this value. So uh, when we will do the georeferencing process, then we will check for this residual this is showing very high value, but after then we will see, check this. Just give me the 1 minutes for this. Okay, go to the fourth point. 25.25 and 82. Okay, now go to the setting and select this one, and output, select the output file, uh, day third, that is the QGIS georeference, and just give its name test file, test dot tif. Save and linear and okay. If you want to save GCP, then GCP point will save. So run this. So this has been georeference. Of course, error is very high. So, but we will check the how much this is deviated from my original. So this is basically a map of the your map of the Allahabad city. That is Prayagraj city in UP region. So we will check this is georeference or not. For this, we will open the our just okay. Just remove it. This one. Uh, just save it and georeferencing. Yes. Okay. It has been saved. So next is what will you do? uh, just browser panel. This must be here. Okay, now new, discard this and open. Go to the desk, this where I have saved our georeferences data. New course third. Sorry, this is basically a TIFF file. So go to the layer. When you add the open any vector file or TIFF file, then go to the layer and add layer. And basically TIFF file is a raster file. Click on three dot and day third QGIS referencing georeferencing in. This is a test file which I have saved just few minutes ago and save. See here the coordinate system. You can see the coordinate system. So now browser panel, select the second browser panel. Where this is the layer order panel. Hmm. Yes, this is the layer panel, and just keep this one here. Okay, keep this here and see here the in previous map which is not georeference. So if the coordinates is not given. So but in this case coordinates are given. But how much you have corrected correctly georeference for this? Then what will you do? There is a tool that is SCM GIS. Go to the plugin and install SCM GIS. SCM GIS tool. Oh, sorry. In why it is not showing this things? Just click on the all. Then I have upgraded, so that's why it is not showing. So when you will SCM right here, so SCM GS is coming. So I have already installed. And what is the this base map downloader, open data batch, and these things you will see here. So I have already installed, that's why it is showing this. So I'm upgrading this. So my GIS is upgraded. So just install. When you will install this, then see the SCMGIS. So in previous case, go to the plugin and click here all. So the tool for the georeferencer, that is geo referencer tool, geo ref georeferencer extension. So install the georeferencer extension and the freehand raster georeferencer. So you install these things. So ZDAL, also install the ZDAL. Hmm. So this is the new name is the georeferencer extension. Old name the georeferencer GDAL. So which I have installed. So please install the SCMGIS. When you will install, then when click here, there is a base map. So I'm going to the base map of the Google satellite hybrid map. So when you will open this, see and just uh, uh, right click and just put here down. So see, it must be overlap on this. So when this remove, so this, see here how much deviated my, this is the river, and river is going from here. So it's my georeferencing process, lots of the error is available. Why this error has been come in third, where I have taken the third points. Just see here the third points, I wrongly interpreted the this exact cross section of this. I think this must be here, and 1 degree is misplaced. So how much? So when you will just go to the test and right click, go to the properties. When you will open this, there is a transparency. So it's go up to the, keep it up to the 28.4%. See, when you will do it this 28.4%, this will be almost transparent. But see here, the actual river is here and the your river is here. So how much distance is this? When this is the ruler, and you can calculate the distance, that is a meter or kilometer. I'm just clicking the kilometer. So I think this is the first meandering river. So just check it this, how much this distance. Then 9 kilometers shifted from here to here. So I have taken make a mistake when doing the georeferencing process for selecting the points, and wrongly select here to R. So you must be cross section of correctly points data. So this must be where this is given, so you have to point out. So then otherwise point out here and here. So this will be take more accurate, because it is given here. So and error must be less than 0.7. In my case error is at 1035, but it is georeference, that's why it is showing given here. When you will georeference ungeoreference map, so I have added a ungeoreference map. So add layer, raster, go to the this SOI, which is not georeference. So this is the map which is not georeference, and when where will this map will go? See, no, this is the already georeference which I have georeference. I think this is another map. So see, this is your correctly georeference map. When I have just keep it just go to the transparent and just click here and see. See, this is my map. When invisible, this is the your Google map, that is your Yamuna river, and this is your georeference map. So see, the georeference maps river and this river is exactly overlap on this Google feature. So this map correctly georeference, but this map is not correctly georeference, and you have seen how much error in this. But this error you have to reduce manually and select the points correctly on this. Must be in cross section point, and conversion point is must be accurate. So you are able to georeference a map. This is the process for georeferencing from the toposite map, in which the latitude longitude information has been given. Now next step is the image to image georeferencing. Suppose that you have a image, so you don't want to this you have a no information of any latitude longitude, but this is a map. So what will you, how can you georeference this? You have already georeferenced this map. Okay, this corrected georeference map, but it's latitude longitude given, and this map is not latitude longitude given. So both are the image. So you have to do the image to image georeferencing process. So This is the process for image to image georeferencing process. So this will we will see this image to image georeferencing process in a next class. So here we will see some tools for this. Suppose that this is a rastered file. Now you want to add the some vector layer. So if you have any vector layer, then you can add this. So these are the save file. I'm just removing this one. So these are the save file of your vector layer. Okay, and make it more visible. And change this. Make this more thick. So these are the lines of the vector. So basically this is a line save file and this is your raster saver. So I want to shift this value from here to here. So what type of the tools I have to select? Suppose that just open this and select this one. So this is a toggle editing tools. So with the help of toggle editing, this when you enable this, these features will be open. So each features have a different and distinct value for the analysis of your vector save file. So I have shared this thing. This is enable only when your vector files is here. It is not applicable on the your this raster file. So what is the purpose of this and what is the functionalities of these tools? I have already shared this to all of you. Just wait. Okay, editing tools. Editing vector layers in QGIS. How to editing vector layers? Various vector layers on table QGIS, spatial, PostGIS, MS SQL, which we have will read on later. So editing in QGIS, before you start editing session in QGIS, make sure you set the right snapping options, snapping tolerance and search radius. So snapping is another tool which we'll see in the case of the your LULC map preparation. And this is the toggle tools, and this will work on the your raster data, sorry, vector data. So when you will enable this, then this is a highlight, and the most of the feature of this is enable, which is and activated. So activate the advanced editing toolbar, go to view toolbars and what digital toolbar. And what will you do with the help of this? I just want to show you. Uh, I'm going to lots of the save file are here. So okay, I'm going to export and one selected save file. Okay, just select it and export this. Only when you will export the saves all features, save only selected feature as. And in save file I want to export, that's why I've taken here, and this is already in WGS84. So where is the location? My location is in D. I give it name as a test vector. Okay. Okay, now it has been now remove this. Okay, now again add layer. Go to the add layer. This is the vector files, and go to this ge- test vector SSP file. Add, zoom to layer, and this is going here. So I want to edit this thing. This location is here, and our see raster file is here. So I want to edit and reproject on this. Sorry, reproject. I want to overlap on this. What will you do? This will be done by the advanced editor tool, that is their toggle vector. So just click on this and go to here, select, select, and this will when you select this this one, then this will be remove this. When see when use this, this is the vertical. Oh, just I'm zoom it, then you are able to just before. Okay, discard. Okay, now I make it just more visible. Remove one layer. Okay, now make it more visible. Go to the properties and symbology. Go to the symbology, change the color. I make it red color and increase its thickness. Okay, when use this tool for the deselecting, this is already selected, that's why it is showing. So and everyone can see this line save file. I want to overlap this line save file on my raster image, which is georeference on this. How to edit these things? So this will be edited by the toggle tools. When you'll click on this, select this first, this, then the toggle tool will be uh, activated. So go to here and select. Now it has been selected. Now click on this, and this will, when you click on this, then this will give you rotation. You can see here rotation angle here. So when this is the rotated at 90 degrees, then this will make here again, make it this. Now my aim is to drag this from here to here. So for this select this, and see here, this will be come here. So again double click on this and save it, and use this symbol for unselected. So you are able to drag your editing for rotating, for overlapping, and all these things with the toggle tool. This is the first feature. And from vector layer you can add layer, go to the for vector layer, for the vector file, for raster file you can add from here, and delimited for text file, for csv file, and these things you can add here. So this is the small feature of this toggle tool, how to rotate your vector file and this thing. And this and next in next class we will learn about the uh, beautiful map for your suppose that you want to make a study area map for your research paper, and georeferencing and the image to image, how you can do the image to image georeferencing in QGIS, we will see. And this raster to vector, how to convert. And these are small things we will see in this uh, QGIS pattern. So I'm going to stop here. If you have any question, please ask. Hello.
No questions, sir.
Okay. In next class, we'll start in morning from 8 p.m. 8 a.m. to 11 a.m. Because most of the
Sir,
people.
9, sir, sir, 9 p.m. is it possible? 8 is too early, actually.
Okay, okay. I
If,
will. I will give a. I will make a Google
okay.
form and
Yes, sir. Yes.
circulate it among you. And if the majority is going with the 9 a.m., then I will select this. I will go through the. Okay.
Okay, sir. Thank you. Thank you.
Okay. Now I'm going to stop here. So if you have any question, please ask, and I will share the some this. Test series and some this today notes and class lecture class notes. So please do and try to solve this. And previous test series only 2% have been tried. So please try it, otherwise this is not very useful for this class, is very useful for to all. So please try to these things. And I've shared to the notes to you, because these are the day 4 class, and this is the very basics class. After then these basics class, the higher version is coming, because next I will not teach the basics of the Python. I will teach the structure query language. So this will be difficult if you don't know about the basics functions and basics of basics terminology of the Python. If, and in a higher case I will use the in QGIS the PostGRE, GrassGIS. So this will be make a different make difficulties for you. So please just go through and see one time, then you can understand this. Just keep in mind what is the least dictionaries, because multi-time I will use things. So thank you so much for watching today's session. So we will meet in next week from morning or 8 a.m. or 9 a.m. It's up to you. I will share the Google share. Thank you. Bye. Good evening to all of you.
Thank you, sir. Bye.